everyone, my name is Anna Baranova. I'm a BIM developer and BIM automation engineer at Integración, Spain. And today we will be discussing how to make a connection between Revit and MIDAS. Before we start, I have to express my understanding that you guys probably not really willing to spend 12 hours with me on the webinar, let alone 24 hours, which this discussion might probably need if we go line by line of code. So I was trying to collect all the information for you, like cherries on tops, in just 1 hour. For just 1 hour webinar, because I respect your time, I respect you have your private lives. So that's why we will concentrate with you more on the concept. Don't get depressed yet, because I think that the concept in our time and the time of this technological era is much more important than understanding of execution of every line. Because let's not lie to ourselves, we all use AI, we all use ChatGPT or any other AI best friend, which one you prefer most. And in this case, it's much more important for you to understand the logic and understand the concept and the idea of what you're trying to do, rather than understand the execution line by line. Because you can give the idea to AI and it will try to help you. Not necessarily will make it exactly right from the start, but at least you just have higher chances to definitely create something, even if you're lacking some knowledge. So I hope that it will be a little bit more reassuring for the ones of you who don't really feel very sure about creating your own tool. At least give it a chance, because I think nowadays you have a lot of a lot more possibilities than ever. Basically ever. Okay, so with that, let's move on. This is a collaboration between MIDAS and Intexa, and our experience and Intexa. And let's smoothly go to the topic. Okay, so you are here probably because once at some moment you googled the tool expert between Revit and MIDAS and X, and you probably couldn't find anything. Well, this is encouraging encouraging news actually, because it means that whatever you create will be innovation, because it doesn't exist on the market, right? I hope it will help you to feel more inspired. But even if, let's say, tool existed, we all tried, or at least some of you, I think, tried the custom plugins that are available for, let's say, for any other softwares, for any other calculational softwares. And I think that you can even write if you had like problems with this, but I can express and I can explain the usual experience that we had with that, usually, like with the plugin that just exists on the market, not made by ourselves. So the experience would be like this, that in the beginning, this really helps to solve a lot of issues. We send, let's say, some not really developed model from Revit, then send it to calculational software. It really helps engineers to create it all, or we can do the backwards thing. So in Revit, we already have some model, even though it's not very, advanced, but still on the low level of details, it's quite good result. But the further we're going in the project, the more developed and advanced both models become, the harder it is to update one with another, because both of them have some details that are not really exist in the other software. So in Revit, you have like some specific constraints, you have dimensions, you have text, you have whatever you might have. Okay, you have like connections inside of Revit, and then you have the MIDAS advanced model for structural analysis model. There you have links, there you have springs, you have some other, I don't know, specific material information that doesn't really exist in Revit, and it doesn't make really much sense to recreate it in Revit. So a lot of information during the export and a lot of constraint during the export basically destroyed. And it comes to the moment when both of the sides, structural engineers and modelers, are just refusing to sacrifice their model, or they sacrifice, but it takes a lot of efforts to recreate it in the way that would, satisfy the final vision of the model. And this happens when? This happens because the expert is not tailored. What I mean with that is that when we just export some general information that is common for all the projects, I don't know, we just share material, we just probably share section or simply only the geometry. When I'm saying geometry, I mean the location line. This information is so small and so basic that we just have to adapt it a lot and add a lot of more details to really make it work and make it look good. And it's not the problem of a tool. It's not a problem of like bad software or bad plugin. It's just the way it is, because every project is very unique, and every project has its own rules, its own algorithms, its own ideas of how to divide elements, let's say, or whatever it can be, that only tailored exporter that we can do with you can really solve this issue. So let me explain what exactly I mean. Imagine that in tailored export, you can not only send the geometry, you also can assign sections, but exactly as you wish, by the rules that you think are better. You can assign materials, you can divide the elements into finite elements exactly by the wish of how your lead engineer wants. You can add effective lengths if you want, you can add links, elastic, rigid, only for this kind of capitals or only for these columns or whatever it can be in your mind. You can add tendons, and you do this all based on the algorithms and specific logic of this project and of this specific engineering team. You also can create groups. You can name them specifically in a way that would be more comfortable for your engineering team again to work with, or even for further automation. So basically, with the tailored expert, you create a possibility not only to send the geometry there and take it back. You basically can just make the after work with your exported model be done not in a few hours manually, but instantly during the export. So the idea, you take the model, let's say from Revit, you send the geometry, but also as you have all the information from Revit with its parameters, with the logic that you know from the engineers, you also can additionally add some very project-specific rules to that. And then you have the model totally exported, not just with the geometry, but with all the logic, all the links, all the groups, all the tendons already added. Isn't it perfect? I think it is. So this is something as an idea that I have to tell you and really encourage you to try. Okay. Perfect. Now let's discuss the theory behind it. So what is clear for us is that somehow we have a model in Revit, and then we have some magic going on, I guess, in the code, and then something going on. And finally, we have this model translated in MIDAS. Do you have any idea of how exactly do we do that? I mean, clearly something is going on in the code, but what exactly is there? Let's dive deeper to understand what exactly should be there. So we will have two tools. We will use Revit API and MIDAS API. I don't know if you will be shared with this presentation, but if you will, you can click on these pictures and it will forward you to the links where you can find Revit API and MIDAS API. Okay, this is when it comes to the APIs that we need to know. There you can find some examples. You can find a lot of methods that you can use and just have like some idea of how exactly to behave with the API of these programs. The second thing that we need to know is that this magical code is not just some specific code. Uh, it is a plugin. Okay, it's not a desktop application. It's not a plugin for MIDAS. It has to be a plugin for Revit. The reason for that is that we will be changing something in Revit model. And sadly, Revit is not really accessible through the desktop applications or the scripts or anything else that is not Revit plugin. So we can change the Revit model inside of I don't know, any external, let's say external software external from Revit. But don't worry, inside of the Revit plugin, we still can change MIDAS model, which is very good. So for our goal to create a connector, the plugin is perfectly suitable. Okay. Okay. And when it comes to the plugin, I really wish we had more time so I could explain you in details how exactly to make it and what is the theory behind it. But sadly, we don't have it. And gladly, I found for you a video where you can find the answers to all your questions. This is a video of how to make your first Revit app. It's 25 minutes, but in the end, you will have the clear idea of what's going on, how to make it, and you can use the template, let's say, that will be created in that video for the further developing of our tool. Okay, perfect. So there you can basically create the base for our following work. Perfect. Let's move next. And when it comes to MIDAS API, just to give you more idea where to find it, you have to go to the MIDAS support website and go to resources and find their API manual. There you can find the examples, you can find some knowledge, let's say some information in theory, how to use it. You can find the MIDAS JSON manual, and this is exactly the thing that you will be using a lot when you will be sending information to MIDAS about some specific element. There you can find what exactly the information that you have to send about this element for this element to be created inside of MIDAS or changed or even deleted inside of MIDAS. So now we have more understanding of what is the general workflow, right? So we will have Revit. Inside of the Revit, we will have the model. From this model, we extract some information with the help of Revit API. All this happening in the Revit plugin. And after this, we write the information in the MIDAS API form and send it to MIDAS. And like this, the info from Revit about the elements that we want to create is somehow converted from MIDAS, from Revit information to the MIDAS kind of information and sent to MIDAS. So like that, the elements are recreated in MIDAS. Okay. To be more specific, we take the information from Revit. We collect only important one because in Revit we might have uh, received so much properties about every element. We don't need all that. We don't need every family type information. We need to know the level ID. There's many properties. We only need something that is useful for us to use it to recreate in MIDAS or to use it for some specific other logic, like for creating groups or whatever it can be. We only collect the important information. And then we translate this information to MIDAS. Technically, we have to separate our, let's say, classes inside of the project in 3 folders. So we will have the Revit side that will work only with the Revit API and Revit logic. Then we have the data core. This is, let's say, the place where the useful information will be stored. This is the place where we write everything that we want to send between our models. We want to send the information about material, so we write it there. We want to send the information, I don't know, about the idea of element, or we want to send something about section, geometry, location. We write it down and we send it. Okay, perfect. And on the MIDAS part, basically, we need a folder with everything that will perform comments to MIDAS. This is a very nice structure because it gives you more possibility to connect additional softwares and use the data core as, let's say, as a general source of truth inside of your workflow. So if at some moment you feel like you would use Excel for whatever the reason, maybe you have some additional information in that place that you don't have in Revit or you don't have in MIDAS, but you would like to restore it in Revit, you can just additionally add like the force folder of Excel and then add additional, let's say, information properties inside of the data core and retrieve it from Excel. And at some moment, maybe you don't need Revit anymore. You just have to work with Excel and MIDAS, or you want to switch from MIDAS to, I don't know, another kind of MIDAS, from Civil to Gen, whatever it can be. And you see that there's like some other logic you want to follow. You also can easily do that because in this case, when all the logic inside of your project architecturally separated, you can remove one part without touching others and just change it to something else. This is very useful and very cool. So just try to keep it that way. Perfect. And also important, as I was talking about the main useful information inside of the data core, I would recommend you to create the custom data types. So here's the example of the element data. And you have to write there something that is important for you for your automation. It could be the ID of the element, its mark, the element type, or the nodes that are included, the material, the sections, and so on. It could include any data types inside. It doesn't have to be some plain like integer or text or string, whatever. It could be anything. It could be node data. It could be even the Revit API classes or something. Because the idea of the data core is that you can keep your information interconnected with each other. And then you will have to have the data types for MIDAS. In MIDAS, it is much more plain, so you don't really have the more advanced data types rather than integer and strings. So, but at the same time, you have to keep them somehow similar, so you would be able to get this important information to the element data of MIDAS. Okay, I hope you get it. If you don't, feel free to ask your AI. Perfect. You know, what a nice time to be a teacher, honestly. And now to my favorite part, to the code. We will not go really deep into that, okay? I'll just show you the code so you can later, again, discuss it with your AI, for example. And I will be showing you very simple code, okay? Not super complicated, but I, again, just want you to get the logic, all right? All right, so now we're creating the very base for your tailored exporter, which means that we're making that base that you might use later for adjusting into other projects. Basically, something that you can take as a general template for other projects, basically, okay, and already adjust to some project rules. Or, I mean, just make it more advanced if you wish, of course. So here is something super simple. All right. Okay. So the first thing we're doing, we're going to be selecting Revit elements, the ones that we want to export to MIDAS. After this, also very important, I'm making the converter. So I'm making a possibility to convert the values in Revit to the normal system, so from imperial system, because in Revit API, all the information is taken and given in imperial system. Okay, so in case if you're not working in imperial system, you have to translate it. So for example, here I have to translate from foot to meter. All right, because I'm working in meters. Perfect. Then we go for every element that we picked. We get its location. If it's a location curve, so if it's a beam, it just takes the start and the end of it. If it's a column, it takes the start, the location point, and then gets the highest point as setup, and then just creates basically 2 points that will represent the bottom and top of the column. Additionally to this, here we're making a catch. We are writing ID of the element, the future ID inside of MIDAS, based on simple counter. So the first column we picked will be first column with the ID 1. The second column we picked is the second, so it will be ID 2. And the beam was, I don't know, picked third, so it will be ID 3, and so on inside of MIDAS. This is not very sustainable, but it is good if we want just to export. And if your main goal is just to have exporter one way, this is a way to go. There's no need to overcomplicate it. Just fully take this approach. All right. Later, we create basically the data of the element. Let me show to you the code behind it, right? And it takes a few inputs. So we need to provide ID, the type of element, material, section, nodes, and angle. In my case, I already have a MIDAS model open, and inside of it, I already have the section and material that I want to assign. So there is no need for me to create it in Revit or to make Revit follow like these specific properties that I have for this section inside of MIDAS. So I'm just saying that, okay, this is, let's say, if this is the column, I give it like the material 1, the section 1, or it could be the section 3, and so on. Here, just a simple explanation of that. The 1 and the 1 that you have here are just hard-coded ID of a section and the material. And here's the angle. Okay, perfect. I add the element in the element.list, and then I just write it. I write down the nodes. This is important. First, we have to write down the nodes, because when we will create elements, we will have to provide the nodes. And if the nodes are not yet inside of the MIDAS, then the elements will just not be created. So when you write down the nodes, you have to send them first. And then you have to send the elements second. That's basically how it looks. I will not comment more. I will just like go through a little bit. So then when you have this webinar as a video emailed to you, you will be able to go through and just take a closer look into the logic. You open the element data, the node data. What else do we have here in this data type? Yeah, no, not much to show. Okay, perfect. Now let's check how it actually looks. So most importantly, you have to have your MIDAS like connected to the API. Then we select the elements we want to recreate in MIDAS inside of Revit. And basically that's it. As you saw, first it was creating the nodes, and only after that the elements. Let's watch it again, right? We select the elements and nodes, then the elements itself. Cool. The geometry is created. And as you saw, the material and the section already exist inside of this MIDAS file. This is also one of the ideas. So in case if you have, let's say, some template you want to use, you're totally welcome to use it. You don't have to create the new file from the start just because you're exporting something. You basically can even add you can even add your geometry to the existing mm, building, right? Existing model. You just have to make sure that the IDs that you're using do not exist inside of the MIDAS model. So maybe in this case, you would have to pick the beginning of the counter of the ID, not from 0, not from 1, but from the last ID that you have inside of your MIDAS model. Okay. So as you saw, we didn't really add the material from Revit. We didn't add the rotation or section from Revit, but of course it is possible. You can get it from Revit API, and here is the ways of how you can get it from the Revit API. I will not comment much, just, this is how you get it from parameters or from properties. All right, perfect. Perfect. And now let's maybe talk more about some kind of synchronization, because what we just did is exporting one way. But imagine we would like to get back the information from MIDAS, or we would like to update the information from MIDAS. How exactly will this model now recognize its like how exactly each element in this twin model will recognize its twin brother in another model, because currently they don't have anything in common. Maybe we could try to work with the coordinates, you might say. So like the twin twin brothers of two different models have the same coordinates, but what if you moved it? What if it's the full idea of updating models is that you move something in one model and you want just this movement to be repeated in another model, right? So here we are totally losing the track. So how not to lose the track? Very easy, right? We have identificator. You really need to have identificator. And in MIDAS, there's sadly not that many ways to identify elements, and basically you just have only one property for that, is ID. In Revit, you have so much more ways to identify element. You basically can just create a parameter to your choice with the name of your choice, and basically somehow state there the name of the element inside of MIDAS. But the most important thing is that you have to have this information shared. You have to have the same identificator in both models. Again, either you have to have the same identificator, which will be much easier to to recreate, maybe like to find or to make in code, but also you can have like a coded identificator that, let's say in Revit, has some letters or some like other things, and then in Midas it doesn't, but you have a decodification of it. So every time you export, you just decodificate one way and another, and you exactly know what which letter means. We will discuss it later for now, but the most important thing you have to understand is that the only way to make element recognize its own twin brother inside of the second model is for them to have some shared information that is stable. So in this case, identificator. And for example, you might think it's cool because Revit has ID, so we can just like copy the ID of Revit and write it down to MIDAS. No, you can't. No, you can't, because in Revit, not sure what is the limit of the length of the ID, but mostly the elements have 7 digits and as their ID. And in MIDAS, the maximum amount of digits for ID is 6 digits. So you already can't do that. No matter how much you try, this idea is failed. This means that we can't use the Revit ID. We have to use like something else. Logically would be assume that we could use mark, because mark in Revit supposed to be unique. Unique parameter and has the unique name. Not necessarily always like this, but let's assume that we will use mark. In fact, you can use any other parameter. You can create your own parameter and just write the identifier there. Okay. And here I need to explain you something that the main idea right now is to somehow write down the identifier that will help one element in one model recognize its brother in another model. Okay, let's come back to the same code that we were working with, but I will just explain what kind of correction we made to make sure that the mark in this case and the ID are the same. All right. One thing that I didn't tell you properly is that of course you have to use the mapk and that you have to use these URLs, like for node it's node and for elements it's elem. Also let me show you write nodes. How does this one look? And write elements. Looks like that. I hope it helped. Let me basically show you the full file so you can take screenshots and ask your AI to repeat it. Don't forget about your MAPI key, has to be there, and you copy it from MIDAS if you remember that. Okay, so basically that's all. And now back to what I was talking about, to marks and IDs. So here we will do something. We will check if there are marks inside of our model in the selected elements. If there are, we will try to parse it to integers, so we know for sure that we can write it down in MIDAS as an ID. If it doesn't exist, we just assign the next available counter, so like 1, 2, 3, 4, and blah blah blah. What is interesting is that if there's no ID, we will have to assign this. If there's no mark, we will assign the mark to the element in Revit before writing it down in MIDAS. So then we know for sure that they will be able to find each other, you know. So if there is some element that has 20 as an ID, of course it will be translated as element with the ID 20 in MIDAS. But in case if there's some element that doesn't have an ID and the last one, like last available was 20, it will just we'll write 21. Anyway, for both of them. So the Revit element will get the mark, our plugin will give it, and the MIDAS element will have the corresponding ID, so they will not be lost. We will keep the connection between them. So I'm basically showing you how it all works. This is very simplified version, but I hope it gives you the idea. Again, the concept in our case is the most important thing. Let's see how it looks like. So as before, we export to MIDAS, finish, perfect, the nodes first, the element second, and then we can select element. We see the mark is 18. Then we see here 18 as an ID for this element. Then let's check this beam. The beam is 20, and in Revit it's 20 as well. Perfect. Now, if we want to synchronize them, the elements will be able to find each other. The 20 will be looking for the element with the mark 20 or ID 20, and the element 18 will be looking for 18, and so on. Here, I will give you a little bit idea because most of you who worked with Revit know probably that mark is usually not such an easy thing that you can just put a number. You usually have like some real codification in there. Or maybe you think that it would be cool not just write the simple number inside of the ID, but make this number mean something more. Here is the example of what we were able to code, or like let's say encode inside of 6 digits in MIDAS. in one of our projects. So we basically used one of the digits to write down the type of the element. So it could be the pile, the dice, the column. Sometimes it is important because you can't really distinguish beams from columns, and they all just of the type beam inside of MIDAS, at least civil and X. And it could be crucial information. And last two was the interesting idea, as we had to separate our element into finite elements. We used the last two digits to count the finite elements. So in this case, we knew that every beam or every node that have 4 first digits, similar, I mean the same, equal, are the parts of the same element. It's just like a few finite elements that are counted. And here already you have more ideas even how to use it. You can count them from top to bottom or from bottom to top. So like this, by sorting them, you will know which one is lower, which one is higher, which one is the lowest, which one is highest, and so on. And of course, here it was already like internal logic for 3 digits. We were trying to write down the logic that we had in Revit as marks. Okay, and so we made like an encodificator to be able to restore the mark from these 6 digits, and at the same time encode the mark to these 6 digits. Okay, so this is just an example. And yeah, let me show you how it looked like, just to tease you how Taylor the expert can work. So we expert nodes, elements, links, saying rigid links, and tandems as well. And as you see, it like saves hours of work, and it was done like in, I don't know what, 28 seconds. All right. So as we talked already about how to use information from Revit and send it to MIDAS, let's now talk how to get information from MIDAS and send it to Revit. Absolutely the same logic. We take the MIDAS information, only collect the important one and send or update it to Revit, and send it to Revit to update or create new elements, maybe delete new elements with the same identificator or encoded identificator as we discussed. In this case, the logic is absolutely the same. We get the MIDAS side element data information or whatever class it is. It could be like group data, it could be tandem data, it could be whatever, in the format that JSON inside of MIDAS API gives us. And then we kind of transfer it into more general and more useful that type of element data, or again, whatever it can be in the data core. So we could now have more information, and we could do something with this in Revit without tightening Revit to JSON files specifically. And I think you will really love this idea. The more complicated your code will be, the more you will like it. All right, now let's talk about the synchronization. The synchronization basically is super easy. We just go through the elements inside of Revit and the elements inside of MIDAS. We get them all. And then we find the couples with the same identificator, or again, encoded identificator, doesn't matter. Like, so we find the couples of twin brothers, right? And we compare their properties. The properties are the same, perfect, we don't do anything. The properties are different. It depends what exactly we want to update. If we want to update Revit from MIDAS, we just like rewrite the properties of this element inside of Revit based on the information that we got from MIDAS. Or other way around, if we update MIDAS from Revit, we like send this information from Revit to MIDAS. Perfect. If there are some elements that no longer exist, we delete them. If there are some elements that appeared, we have to create them based on the information that we are provided with. Okay, so this is basically just the same thing. We just have data core in the middle of all that sends the useful information, and this useful information are found and compared between each other based on the identificator. That's it. Like, this is the full concept. It's actually easier than it looks like. Now let's check how we can okay, how we can actually transfer from MIDAS to Revit. In this case, I deleted the frames that I had and in Revit, and I will move the beam here inside of MIDAS, so so we can see how it will be recreated with a little change, because in the end of the day, we just will not throw the same model here and there. We will have to like send it with changes and so on. So in this case, I will move it for 2 meters, and let's click import from MIDAS. And boom, we have the model created. That's it. Like even with this moved beam, everything is in place. Amazing, perfect. Let's move. Actually, let me show you something. Let me show how the export from import from MIDAS works. So as before, node URL, element URL, I'll hear your API key. Important in this case that you don't have to forget. You have to send the information to Revit in the imperial system. So you have to like convert it back to the imperial system in case if you don't want to use it. Then we just receive the information from MIDAS. We received the JSON of nodes, then we received the JSON of elements. Okay, let me show what's going on here. We recreate the node data, we recreate the element data to get it all very accessible. And basically, that's it. We here specifically, I don't create section from MIDAS, because again, this is all just for simplicity. You might want to like recreate the same section, or you might want to use the databases of metallic sections, or there's so many options of what you can do. So here I'm just looking for the first elements of the category, and that's it. You can look for the element that has the same name. It also could be an option if you have like some specific names of the sections inside of MIDAS, for example, and you could use the same in Revit, recreate the same in Revit, and then make a warning like, "Hello, you have to create this one. It's missing," and then your modeler will have to do something about it. So there's a plenty of artistic choices you can make when you develop a plugin, and you're like fully free in your strategy of tailoring it and tailoring the workflow. Okay, so yeah, basically just create the like the beams or the columns based or the structural elements based on the information that you just received. So it will be in this case the geometry and so on. Here again, I'm making very, very, very simple code. I will go through just for you to have like the full access to it. But this is something very simplified. I think that once you will start really developing, you will make it more complicated. You will you will add more loops. You will add more if statements, more conditions, and so on. So all totally tailored again to your workflow and your vision. Perfect. And here, as like the final things that I would like to show you is first the bottlenecks about the like data types. I don't know if it's useful for you. Could be. Again, it was just important to keep it inside of the plugin, so everything would be interconnected. Like here, the profile point is a new data type that would be easily accessible, and then when you create a tandem, it's easier to access it rather than go through the full JSON file and get like some points, whatever. Doesn't matter. So yes, additionally to what we did, you could create some tendons. Here, how it looked like in our project, and here's the data type that you could create to make it. You also can make groups. This is the group data and how it looked like in our project. also very useful, and you can easily add as many groups as you want, and you can make so much order in your own model from Revit, because in Revit, we have categories, we have like other kind of properties of parameters, like you can really separate um, one elements from others that otherwise would be a tedious work to do, like would be really hard to do. Um, so I really suggest to make groups if you can, especially if you plan to make the following automation. And of course, you can add links. This is just some tips of the data types for links. Okay, this is the right way to do that. Okay, and let me tease you a little bit. This is the full workflow that we were able to make. So first, of course, there was the expert, and then just because the expert was already so great and tailored, even not only in a generational way, but also in a way of preparing the information inside of the model, making the perfect groups, having really telling IDs that we could encode into some really useful information, we could easily detect which element is which element and which node is which node. We could really understand to which node we need to assign uh, let's say the collision load or the wind loads, and based on that we could make an algorithm to prepare automation. So instead of assigning it all manually, we could do this all automatically. So as you see here, we basically just first create this informationally rich model. Then, because it's informationally rich, we can continue enriching it with the automation, and we would set springs based on Excel. We would generate loads based on just the groups and the logic, and then we'll run the analysis. Okay. After this, we would set stages, and also I think the next one was combinations, and then export the results. So altogether, just about 8 minutes. Otherwise, would take so much hours to do. And I hope that this will be just additional inspiration for you, an additional reason to generate the model and generate it in a smart way. I hope I gave you a lot of ideas today, and I hope you really went a lot to your AI of how to make that all. Okay, thank you very much. I think it was very good, and we are really good on time. I think that we really made as much as possible in 1 hour. And yeah, also, if you have any criticism about me, if you feel like I was wrong in something, or you think that some parts could be executed better in code, or you have some interesting ideas, feel free to reach out on LinkedIn. I am totally open for the criticism, and yes. Okay, so thank you so much for for your concentrations. Thank you for making it till the end. And yeah, that's it. It was really nice to have you here.